welcome back. So I just flipped the coin a few more times and filled out the rest of this little table. And now we're going to think, how can we analyze the data? So one way we can do it is find the average position, or x bar, the mean value of x, at each step. So if we do step 1, 2, 3, 4, 5, 6, 7, 8 again, x bar, the average, well, looking at the first one, it's minus 0.2. The second one is going to be minus 0.4. Oh, drat, I've not got enough space to really write these numbers clearly. The third is going to be minus 1. The fourth is going to be minus 0.8. The fifth, the average position there is going to be, let's just do this one in a bit more detail. Let's just highlight these numbers. Plus 1, minus 3, minus 1 is minus 3. Plus 1 is minus 2, minus 1 is minus 3 again. So that's minus 3. We have 5 walks, so minus 3 divided by 5 is going to be minus 0.6. For the sixth step, plus 2, minus 2, and minus 4, that's overall minus 4, so that's minus 0.8. And for 7, that's plus 3, minus 3, plus 1, plus 1, minus 1. That's actually, I think, 0.2 plus 0.2. 0.2, and for 8, plus 2, minus 2, plus 2, plus 2, minus 2, plus 2. So 2 divided by 5 is plus 0.4. And if we make a graph, so this is the mean position. I've drawn that off the edge. Let's try and draw that again. X bar on the vertical axis, and step here. So I'll put some markings on for these 8 steps. So first step, we go to minus 0.2. I'm going to say that's about minus 1, that's about plus 1 here. So that's minus 1 there and plus 1 there. So the first point is there. Second point is a bit lower. Third point, we're down at minus 1. The fourth point, we're at minus 0.8. Fifth point, we're at minus 0.6. Sixth point, we're at minus 0.8 again. The seventh point, we're at 0.2. So we're just up here. And at the eighth point, we're at plus 0.4. So these numbers are all very close to 0. They're all sort of between minus 1 and plus 1. And as we might expect, if we're randomly moving forwards and back and we look at lots of paths, on average things will have a position of 0. So we don't really learn very much from that. But what we could do is, actually that's not quite true, we don't learn very much from it. One thing we do learn from this is that we are randomly moving left and right, and so the number isn't exactly 0 for x bar all the time, but it's reasonably close to that number. What we can do, though, to get more of a feel for things, is square x and take the average. And so that means that any negative number becomes positive, and we get more of a feeling for the distance moved away from the origin at the beginning. So for step 1, then step 1, the average is going to be total of all of those 1 squared, 1s and minus 1 squared is going to be 5 divided by 5 steps. So the average is 1. For step 2, we have 4 plus 4 plus 4 is 12. Take the square. 4 plus 4 plus 4 is 12. And so the average of that over 5 steps is 2.4. For the third step, we have an average of 1 plus 9 plus 1 plus 1 plus 1, so that's 13. So that gives us an average of 2.6. And then for the fourth step, we have 0 plus 16 plus 0 plus 4 plus 4, so that's 24, so it gives us an average of 4.8. For the fifth step, which is circled, we have 1 plus 9 plus 1 plus 1 plus 1. Oh, that's 13 as a total, divided by 5 gives us 2.6 again. For the sixth step, it's 4 plus 16 plus 4 again, that's that's about 4.8 again. For step 7, we have 9 plus 9 plus 1 plus 1 plus 1, so that's 21. So that gives us an average of 4.2. And for the last step, actually they're all plus or minus 2, so they're all going to give us 4 when we square them, so that gives us an average of 4. Now this sample size isn't really very big, so we're not going to get a good average of exactly what x squared does, but I'll sort of just do a rough plot here. 1, 2, 3, 4, 5, 6, 7, 8 steps. So let's say that maximum is about 5, so we'll say that's 1, 2, 3, 4, 5, 6, 7 on the scale. So our first point is here at 1, 2.4 then, 2.6 is slightly higher, 4.8 is a way up here for step 4. Let's see, that is hang on, this is only a rough plot, I probably got that wrong. The next one 2.6 again, next one 4.8 again, the next one is 4.2, so that's just a little bit lower, so we're in about here. The next one is 4. Well, we can't tell yet exactly what's happening there, but the points do seem to be getting further away. So the mean of the squares does seem to be sort of increasing. We can't tell what the shape is yet, but we've only done 5 walks, so we don't really have very much about this. So, but I hope what this illustrates is just how we might start to attempt to look at a random walk and simulate it and get some information. So that's going to be the end of this part. So in the next part, what we're going to be thinking about is how we could get a computer to do this, because this is a bit laborious to do it by hand and flip coins, and we really want to be able to do this for lots and lots of random walks. Okay, so